Hello and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifetime learning and serving the over 100,000 computing professionals and students who are ACM members. For those of you who don't know me, I'm Will Trace, Lockheed Martin Fellow Emeritus and Chair of ACM SIGSOFT, a special interest group on software engineering. I'm also a member of the ACM Professional Development Committee who is bringing you this webinar today. And I've served as editor of ACM SIGSOFT Software Engineering Notes. You've all had a chance to read the housekeeping slide, and you probably, for most of you, have come in and seen the highlight, familiar with ACM. So let's move on to the housekeeping chores, and that is the fact that you know how to refresh your browser, and you can control the volume, and you know that we're going over questions and answers from the previous version of this webinar. We will be taking additional questions of clarification as you think of them, or perhaps would like further elaboration. We also have the Facebook and Twitter widgets at the bottom of your panel, which you can use the hashtag ACM Webinar Agile to tweet if you so choose. With that, I'm going to turn the presentation over to Bertrand after I briefly introduce him. Once again, this is Agile Methods, the Good, the Hype, and the Ugly, Part 2. Bertrand is a pioneer of object technology and author of several bestsellers, software engineering, programming methodology, and programming language. He's known as the creator of Design by Contract and the Eiffel language. He's currently a professor of software engineering at ETH Zurich, and he is an active consultant and speaker and made major contributions to the fields of software verification and programming. Also acknowledge the fact that Bertrand is a 2008 ACM Fellow. Bertrand, we look forward to your presentation today.
Thank you very much, Will. So actually, it's not a presentation. The idea is to answer questions, and so there's already a list of questions that were sent after the previous webinar. And in fact, I'd like to thank everyone who participated who listened to the webinar, but even more, those who contributed questions and comments. This was all very gratifying to see all these people excited about Agile ideas and interested in taking them deeper, analyzing them deeper. Will, what is the procedure if people want to ask questions now? I mean, I don't assume that we're just going to go through the list of pre-recorded questions. So if someone wants to add a question now, they know how to do it, and you are going. So I think they know how to do it, but I'm not sure how I get the answers, the questions from you.
I hope this proceeds as a dialogue, and I will ask you for clarifications or comment on your comments. And similarly speaking, if a good question comes in, that being that I also have the list of previously answered questions, I will interrupt you and pose that question to you in real time. So once again, for all you in attending, you have the Q&A box. You can type in a question, and I will be happy to inject that as appropriate into Bertrand's stream.
Okay, great. So I'm going to take questions from the list that I have, not entirely at random, but I'm not going to start from the beginning. So there is a question from Ajoy Bhatia, and I'm sure I'm mispronouncing the name, but I hope that he or she, I guess it's he, will realize that that's their name, Ajoy Bhatia. And let me read the question. The question said, does the bias against big upfront efforts, big upfront in quotes, come from programmers trying to wrest control of the development process from architects and reassert their importance? So that's the question, with a comment that Mr. Bhatia added, part of the challenge of avoiding upfront requirements and to approach the implementation through a series of rapid iterations is that it is hard for senior management to understand where the project stands with respect to the overall schedule or versus the overall schedule. How do we fix this? So it's really two separate questions. So let me address the first one first. Does the bias against big upfront efforts come from programmers trying to wrest control of the process from architects and reassert their importance? Well, actually, I don't think so, because certainly not good programmers, because programmers need something to work from, and in my experience, programmers actually are more happy if they can have some basis to work from rather than to have to invent everything on the go. So there maybe the push from programmers is a little different. I think programmers like to be associated with the upfront tasks, if any, with tasks such as design and analysis. So in the, say, old-style programmers were people to whom you handed a description of tasks and all they had to do was to implement. And of course, this is not a very pleasant position to be in, especially if you're a creative programmer. So the reaction of programmers is indeed often that they want to be involved in the design and even earlier in the analysis, and in fact it's completely legitimate, and it's a very bad idea for a process to not to take advantage of the intelligence that programmers can provide. But that does not mean that they don't want an upfront process. Any reasonable programmer knows that it's really important to think before you jump, or think before you shoot, whatever metaphor you prefer. And regarding the second part of the question, it's more of a comment. Part of the challenge of avoiding upfront requirements and to approach the implementation through a series of rapid iterations is that it's hard for senior management to understand where the project stands versus the overall schedule. So yes, this is absolutely true. If you don't have upfront requirements, it's very difficult for managers to relate progress to as seen from the technical team to progress as seen from the business viewpoint. A programmer or a project leader comes to you and say, finally we managed to get the intercommunication module together, and it's very difficult for you as a manager, as a business-oriented manager, to relate to understand this. You can understand it technically, but what does it mean for the project as a whole? And one of the benefits of having upfront requirements is that people cannot tell you stories. They cannot start going into all kinds of different directions by telling you things by telling you about things that are not really relevant to the customer view. So having a set of requirements describes the needs in terms of the business view and keeps everyone honest by making it impossible to forget the connection between technical achievements and business achievements. So actually, I'm sorry, this is a different question. So, Will, did you think I answered that question properly?
I think I'm just going to jump in and pose you questions to see how, to allow you to concentrate on answering the questions rather than looking for questions. So I'm going to, I've noticed a large number, well, a handful of questions focused on non-functional requirements. And you did not get a chance to address anything about the quality requirements about, and Agile basically concentrates totally on functionality. So would you spend a few minutes elaborating on the importance of non-functional requirements, quality requirements, and how either the Agile, you've seen some of the Agile methods address them or not address them, if you care to comment.
I have not seen very much in Agile methods addressing non-functional requirements, and I wouldn't hold this against Agile methods, because honestly, this is one of the weak points of software engineering in general. We've become pretty good at describing what systems should do. That's functional requirements. We're not so good in general, and not just the Agilists, as to describing and particularly enforcing how it should do it in terms of quality, in terms of response times, in terms of overall business requirements, and so on. So yes, Agile methods don't have much to contribute there, but it's an open problem in software engineering in general.
Okay. Now I have two questions here, so I'm going to scroll on the screen. It'll take me a while to get both of them out in the open here, but they all have to do with test-driven design. And the first one is test-driven design not a great way to clear out ambiguous requirements? So is it not so ugly? And the second one was, there it is. Please speak to design by contract as it applies to test-driven design and methods. So.
Okay. Yeah, these are two great questions. I would say they're quite different. So allow me to answer the first initially and the second one separately. So test-driven design. So technically, I think one can make a difference, as quite a few authors do, between test-driven development and test-first development. I said design, but I think development is the more common term. So, the basic idea is one that is definitely one of the great contributions of Agile methods, and I hope I made this clear enough in the book. The resulting view, which I think is absolutely remarkable and a major benefit to software development, which has already occurred, is the idea that you never add a piece of functionality without also adding a test associated with it. And just drilling this into the heads of a development team can has the potential of making the development much better, and the result of the development much better than it would be otherwise. And this is one of the things that we really have learned from Agile methods, and in particular, I would say from Ken Beck, because that's largely his personal contribution. So, never even think of writing a piece of functionality without adding a test to exercise it, and immediately run the test. So the place where I think extreme programming goes too far, is too extreme, so to speak, is the idea that these tests are a substitute for specifications. A test is concrete, it describes one case. A specification is abstract, it describes all possible cases. And so this exaggerated view of the role of tests leads to the next step, which is not just test first, but test-driven development. And if you take Ken Beck's book about test-driven development literally, well, basically he tells you, write a test. I mean, he describes a process whereby the basic iteration, the basic loop is write a test, run the test with existing code just to check that it fails, because since the functionality is new, the code should fail. Then fix the code to pass the test, and then fourth step, which of course is crucial, because otherwise you would end up with a very fragmented code, very ad hoc. It's a refactor to make sure that the solution is not just specific, but general enough, and then repeat. And I think there are very few people who actually work like this for a good reason. It's that it would lead to really piecemeal software that has the property that it passes the tests, but it has no reason to pass anything else than the test. And the difference between a test and a specification is that a specification is going to abstract from individual cases to describe a general rule, and it's not appropriate to tell people that they don't need specifications anymore. And so that part is the ugly part of the role of tests, of the way Agile methods promote the role of tests. But the really good part has been to rehabilitate tests, put them at the center of the development process. They describe tests as an artifact of a software process, which is as important as the code, the other major artifact. The mistake, I think, is to exclude yet other artifacts, like for example, specifications. But I'd prefer to retain the positive contribution, which is this moving of tests from a somewhat peripheral place in the development process to an absolutely central place, and this has already happened. I think any competent development team today understands that the regression test suite of a project is one of the major assets of the project. So the second question was about contracts and tests. So I really don't want to talk too much about my own work and my own stuff. I think this is not the purpose of this particular presentation. Of course, in a way, that's what I want to talk about in general, but no, because any reasonable researcher wants to talk about his own work, but not particularly today. So what's important to mention here is, again, the relationship of tests to specifications, because a contract is a specification. And test-driven development says, produce a test and write the code to batch the test, to pass the test. And design by contract says, write a specification, and from that specification derive the code. And the specification in design by contract takes a quite precise form. For an individual operation, a routine, a method, it takes the form of a precondition and a postcondition. And for a class as a whole, in an object-oriented context, it takes the form of, in addition, the invariant of the class. And the two, of course, are not incompatible, working with tests and working with contracts. However, there is it's not symmetric here, because you cannot really infer a specification from a test, but you can infer a test from a specification. If let me take the following example. I don't think I mentioned it in the seminar. I probably didn't have the time. So here's a function which I'm going to give you some hints about the function. It's a function from integers to integers. Let's call it f. And let me give you some examples. For 0, it gives 0. For 1, it gives 1. For 2, it gives 4. For 3, it gives 9. For 4, it gives 16. Okay, so the question is, what is the function? And actually, for good measure, so the first question is, what does it give for 5? And I'll be nice, and for good measure, I'll tell you what it gives for 5. It gives 25. But then the question, of course, becomes, what does it give for 6? So, of course, anyone in his right mind is going to say, or anyone in his almost right mind is going to say, well, this is a square function. Now, at some point, and I put this in a blog post, in a blog article a year or two ago, I took this example, and just for fun, I run the values for 0, 1, 2, 3, 4, and then also for 5 into a function, a curve interpolation program that I found on the web. And sure enough, of course, it gives the square function, but it gives quite a few other functions, some really, really bizarre, with lots of complicated or advanced, I should say, mathematical operators, which also match the first 4 or 5 or 6 values perfectly. And this was for fun, of course, but I think it's absolutely representative of the limits of tests. And a test gives you individual values. If you run one test, it gives you 1 point of the specification. If you run 1,000,000 tests, that gives you 1,000,000 points of the specification, but you still don't have the specification. On the other hand, if I tell you this is the square function, and I have an implementation for it, derive some tests for that implementation, then it's rather easy to do so. And so contracts are always going to beat tests as tools for specification. The one thing I should mention here is that at ETH there was a PhD thesis a few years ago. I think he defended in 2008. The PhD student Andreas Leitner, who is now a manager at Google, had this idea of what he calls CDD, contract-driven development, and we have several publications on this. If there's a way to put some references later on, I'll put a link on the page. And so contract-driven development is very much like TDD, like test-driven development, but with a focus on specifications, on contracts rather than tests. And so, for example, one thing that TDD does is, which is integrated in the Eiffel Studio environment, is that if you run an execution and it crashes and it fails under the Eiffel Studio environment, under the interactive environment, then it creates a test from it. And so this assumes that you have code equipped with contracts. And a failure is typically when a postcondition is violated. So I'm so sorry that the answer is a bit long, but I think this is interesting stuff. I hope it's interesting stuff. So you have a routine and a method, and it has a postcondition that says that the result is positive. And then you run it, and the result is not positive. So the whole thing fails, and usually, I mean, this was Andreas Leitner's observation, usually that's it. For you are going to fix the problem, and this whole piece of information will be forgotten forever, that at some point the code was wrong, and it's bad. It's because it should become part of the regression testing suite, but it cannot be part of the regression testing suite until it's a test. And so with the CDD tool, which is integrated in the environment now, which came out of his research, what it does is that from that particular failure, it actually produces a test case by analyzing the state of the execution and producing a test case, which now becomes part of the regression test suite and can be run again and again for eternity, as regression tests should be. So I said I wouldn't talk too much about our own work, and I'll stop here. But there are some really interesting connections between the notion of test and the notion of contract, and people who are interested in learning more about this thing can look up the papers by Andreas Leitner and other members of our team here on CDD, contract-driven development.
Good. So now here's a question that I will paraphrase that has to do with it has to do with the members of the software development team. And the comment was, it seems like Agile hinges on self-organization, but self-organization requires education and training. And would you comment on the fact that why don't more Agile methodologies embrace or promote programmer development training?
So I don't have statistics or credible empirical evidence as to this. In particular, I really don't know whether Agile teams are more into programmer education than non-Agile teams. But certainly, I believe that our field, the software development field, is in bad need of much better programmer education. I keep being amazed at when interviewing potential prospective programmers, whether in an industrial or an academic context, as to the holes in the training or in the education of programmers, even programmers who have on paper an impressive CV, have been working for various companies doing interesting stuff. If we compare with other disciplines, I have the impression that the requirements are much less strict, much more lax in our field than in others. I mean, if I try to transpose to electrical engineering or mechanical engineering or other engineering disciplines, it's hard to imagine experienced professionals failing to answer basic questions, for second-year bachelor's questions, the way I see it regularly in my interviews. And so, now this is explainable in part by the fact that everywhere in the world we have more programmer positions to fill than programmers, and so we tend to bypass many of the expected education steps. In particular, we hire lots of people to be programmers who are very smart and able to learn, but who have not had a formal computer science education. Which, by the way, also means that in the academic world, all the great efforts that we make to improve computer science education have a limit, because most programmers, in fact, have not had the opportunity to to study for and receive a computer science degree. So the problem is broader than that, and I wish that companies were much more generous than they tend to be in general as to continuous education. Companies should keep sending their programmers to education, and I'm not just talking about technical education on specific tools, the Ruby in 3 days, or become an advanced expert on this or that technology du jour, which is the kind of training that companies do send programmers to, but advanced general computer science and software engineering education. I think the industry as a whole would greatly benefit if all these programmers who have all the aptitude to become great programmers, but have not had the chance of a top computer science education, could be sent more often to courses to refresh and improve their basic knowledge.
Well, I think I'm going to follow up with a question that was submitted from a person who was a master's degree student, and he said, is there, and the question is directed on, can we improve Agile methods? Is there research or study to enhance what it is there? And that is sort of an open-ended question, because I think you properly clarified what is good, ugly, or bad about Agile methods, but I would appreciate if you had 5 minutes just to hear your opinion of what research topics might be fertile ground for any researchers or any developer out there who might see something on the horizon that would help us all do our jobs better.
Yeah, that's a very good question. So let me give you a couple of answers. Starting with something which is possibly for me the most important, it's a kind of an irritant. There's excellent research in software engineering. There's no question about it. In particular, one of the communities to which I think I belong is the software verification community, which is quite far, in fact, from Agile methods. And so in that community, there's a lot of work and I'm part of that work with my colleagues to prove programs correct. There's also there's also software engineering work which has been very successful about requirements. So there's there are conferences on requirements, journals on requirements, PhDs on requirements, and so on. These are two examples of important software engineering topics: verification and requirements. Have little to do with each other, but they're just examples. So I could name more examples of research, of successful research fields in software engineering. And the point that strikes me about both of these and many others is that they do not pay much attention to change. It's very difficult to talk seriously about software, at least to talk practically about software development, if you don't take into account that things change, that we live in a changeable and changing world, and that most requirements are obsolete the minute they are put to paper, and probably even before that. So the Agile people take the wrong conclusion from this. They take the conclusion that requirements are useless, and of course that is completely wrong. It's as a deduction, because the requirements may be partly obsolete, but they're still very useful. However, in terms of software engineering research, it means that we should pay much more attention to this phenomenon of change. For example, in verification in general, in programming methodology, there's a very successful idea which is refinement, program refinement, and I'm not going to describe it because it would take too long, but it's the basic idea that you start from a very high level version of the program, maybe just a specification in fact, and then using mathematically guided transformations, you refine it little by little in something that is closer to implementation, so that at the end you actually have an implementation, but each step has been mathematically proved. So that's one example of a very fruitful idea, refinement. In requirements, there are also lots of very interesting ideas. I'm not going to give examples here, but I've seen really little work that explains how refinement, on the one hand, or requirements methods, on the other hand, fare when the problem changes. Do you have to do the entire refinement process again, or can you do better? And so this is an example of a research theme that would really be useful. Agile people, as I wrote in the book and mentioned briefly in the webinar last month, or a few weeks ago, the Agilists are very quick to tell us that we should be open to change, but they give essentially no technical solution to supporting change. And this is where software engineering research can help a lot by studying the effects of change on the proposed techniques, or the other way around. What are the techniques that actually fare well when the specification changes? The only in the history of the world, I think there's been a single case of a software project whose requirements did not change throughout the lifetime of the project, and that was the computation of the 7th Fibonacci number. But as soon as you have anything beyond that, then you know that requirements will change. I mean, it's a law of software engineering. There's essentially no exception to that. And so software engineering researchers should study this phenomenon of change and see what methods support change and which methods don't. So a second point, a second part of the answer is that it's really important to break the fences, the barriers, the boundaries between subfields of software engineering. I was having this discussion with a colleague actually the day before yesterday, a well-known software engineering researcher, and she was asking, well, what exactly is software engineering? Well, what exactly is software engineering research? Is program verification software engineering? Is, process, the study of processes, like in Agile methods, software engineering, and so on. And it's not the same people who would answer yes to a variance of this question, is X part of software engineering? And it's bad. So what I've always tried to do is to avoid specializing myself too much. Of course, when you do specific work, in particular specific research work, you specialize, but you should still be aware of the a broader picture, and there are too many sub-communities. And what I found is that by keeping a broad perspective, by being interested in programming languages, in software verification, in concurrency, in user interfaces, in methodology, in software process, in agile methods, and so on, even though these are usually the purview of each is the purview of a different community, by being able to cross the boundaries between those communities, you can do much better work. So that would be my second piece of advice to the master's student who is asking this question. Look beyond the immediate specialty of a particular course, a particular textbook, or a particular research group. And the third and last point that I would like to make in response to your question is that empirical software engineering research is very useful. This is one of the big advances of the past decade or two. It's that we now have methods and tools to put some claims to empirical study. There's been considerable development there. Some of it more successful than other, but it's very promising. So when I say some of it more successful than other, and I realize I'm far beyond the 5 minutes that you suggested for this answer, but I'm almost done.
No. Please continue.
Thanks. Empirical software engineering means that you don't just take methodologists or people like myself or who say, well, this is the way to go, this is better than the competition. You don't just take them to their word, but you actually put their claims to test, to empirical tests. Tests being used here in the sense of scientific tests, the way a physicist puts a hypothesis to a test, or a chemist, or a biologist. And except that in our case, the objects of study are not materials or physical objects or animals, but they are software. So software elements. So there are two kinds of empirical research, the two kinds of things we can measure and study in software and empirical research, products and processes. And of course, in the Agile world, the most interesting the biggest focus is on processes, but also you can study products. So process study has not been very successful. There are lots of people who have tried to determine the value of pair programming, things like that, but it's very difficult for all kinds of reasons that are easy to figure out. What has been more successful is the empirical study of products, because we have all these repositories, in particular of open source projects, but also of some commercial projects, going, Linux, Eclipse, Apache, and so on, going back 10, 20, sometimes 30 years, and, all the bug fixes, all the commits, all the compiles, the bug reports, and people have been applying data mining techniques to this left and right, and we've actually learned a few things. And it would be nice to have all the claims that people make in software engineering methodology systematically put to credible experimental analysis. Those were my 5 minutes.
And those were, while you were answering the question, I was going down the list of attendees to see what the demographics here, and I would say 80 to 90% of our listeners today are from industry. And but that said, that was a very good answer for those people wondering what perhaps might affect their job. But I'm going to pull the question back to one now that has to do with maintenance. and whether there's any hope, or whether you would like to. Actually, I'm going to ask two questions. You can take your pick of which one you want to answer. Is there any way that sprints are applicable to the maintenance of software products? And the second thing is there any way or advice that you have for the practitioners to convince their managers that maybe Agile is not a good idea, and that somehow or another management has got that we're going to do this? And other than, I would say, buy a copy of your book, but that's easy for me to say, and I know you're too humble to say that's a good answer. But nonetheless, take your pick. What question or both you would like to answer?
Right. Okay. So let me start with the second one. I really don't want to tell managers not to adopt Agile methods. And actually, there are probably some managers that would be all too happy to adopt that principle, and these are not necessarily the best. I mean, there's definitely a class of managers who are, Dilbert boss types who want to rule everything, also who are wary of any idea that is going to empower the team more, and I don't particularly want to encourage those. And so the message is more, is not reject Agile methods. The message is more keep your reason, keep your head cool, and you're a manager. You're probably there not just by luck, but because there are a few things that you understand about the business, and if you're a software manager, about software development, and not everything that you've learned in your previous experiences is stupid. Much of it is actually quite relevant. So look at these Agile texts, these Agile proposals, and don't believe everything you read, but pick the best for you. Pick what's going to work right for you. And if you see a claim that doesn't make sense, it probably doesn't. And it's not you; it's they. Keep your analytic reasoning skills, and don't believe everything that you read. And particularly don't fear being ridiculed because you're not adopting the latest gospel chapter and verse. And it's not the gospel, but there are lots of good ideas there, and choose one. Choose the ones that are going to work for you, without starting to kneel and pray. And
very tactfully.
Thanks. And with the
maintenance.
The first question. Remind me of what the first question was.
Well, the question was, is there an application of Agile methods in particular sprints to address maintenance, software maintenance?
Oh, yeah, right. So I think the short answer is no. This is one of the bad aspects of Agile methods, because if you read all these texts by people, actually I'm not going to single out any particular author, sorry, but if you read all these texts that tell you don't worry about reusability initially, don't do upfront design, don't worry about extendability, object technology is not a magical, is not a silver bullet, and so on, then basically what they tell you is focus on the short term. And the trick about the secret about having about good maintenance is that you don't have to do maintenance, right? The best way to handle maintenance is to avoid it. And the secret to that secret is that you build your systems so that it is well structured, that it applies information hiding everywhere, that is decomposed into good modules, and that it is ready for extension, reuse, and all the good things that happen to good software later on. And here, the whole Agile push towards solving the problem of the moment now and leaving the future for later, all of that goes directly against improving the nightmare of software maintenance.
Good. Here's a question that just came in, and It's actually a multi-part question, but first is the statement, can an organization balance big design up front and agile methodology? That is, deciding the platform, the language, and the major subsystems up front, then use agile methodology on the subsystems.
Yeah, absolutely. I think this is also a very good question. And the Agilists have a point when they criticize upfront work. You know, the problem is not so much with the overall critique of traditional software engineering, which in many respects is opposite. The problem is with the exaggerated conclusions. So when you read that people have been devoting too much work to upfront work, to upfront tasks at the expense of actually doing things, this critique is largely right, and it is true. So people sometimes use the term analysis paralysis, and the phenomenon it describes that does exist. There is a risk that you spend all the time in, I don't want to shock too many of your listeners, but let me use the term anyway, in foreplay. So foreplay is great, but you also need at some point to engage into the real thing. And so the traditional, the standard agile critique that don't spend months describing what you are going to do, just do it, is quite refreshing. It has been quite refreshing and accurate. And so I think the secret is the following. Let's take requirements. Okay, we could say the same about design, because upfront work is essentially analysis, requirements. That's category 1, and category 2 is design. So let me concentrate on requirements just to take an example, but much of what I'm going to say would apply to design. So the agile critique is to say people spend too much time on requirements up front, and that's bad because we don't really know what the system will be. The stakeholders, the customers don't really know. They will only really know when they see a first version of the system, and in any case, even if they knew, it would change. And all this is absolutely right, and this critique has been very refreshing. What is wrong is jumping to the conclusion that we should not do any upfront requirements at all. That is a real catastrophe. And so the secret, the just promised secret, is very simple. You do the requirements, you do this upfront requirement work within limited time. You make sure that it doesn't last forever, and then you treat the requirements, the result of this requirements process, say the requirements document or the various documents that result from the requirements process. You treat them as an artifact of the project, and like any other artifact of a software project, it's something that is subject to change. I mean, it's not because you write a piece of program code that it's there forever, unchanged. You change it. It's not because you write a piece of design that it's there forever. It's not because you write a UML diagram that is there forever. Well, the same applies to requirements, right? You write requirements artifacts, and then you treat them as some of the assets of the software project, and like everything in software, it changes. That's the definition of software, right? Software is soft, it changes. So you don't treat the results of the requirements process religiously, reverentially, as something that is given from the top of Mount Sinai and can never be changed. You treat it as a useful element among many others that is going to guide your work. So this is the kind of reconciliation I would see between having upfront work and having an agile process. The upfront The traditional view tells you produce requirements. The Agile view tells you, or should tell you, a well-considered, a better understood Agile view should tell you, put your requirements into the configuration management system and be ready at every stage of the process to look at them again, examine them, question them, and change them if necessary. This, to me, is the best combination of the two philosophies.
Good. I must say, just as the moderator today, the reader of all the comments, I thank all you listeners for providing some interesting comments, sharing your, I won't say frustrations, but let's just say less than ideal work experiences dealing with management or requirements, or the fact that businesses seem to focus on making money instead of, the good is, quality, speed, and and cost. Pick any two. That comment seems to have come up quite often in the comments that have been submitted, and I know I should be asking Bertrand a question here. So here's a question that came in early in our.
No, but I actually. If I can jump in, the questions are indeed all very interesting, and I mean the ones I saw or heard from you, and I really appreciate them. So your comment is quite appropriate.
So here's a question that came in early in our original presentation that was on Ambler's Agile blocking. That is misreporting status, lying about progress, falsifying deliverables to keep a project moving forward at any cost. Do you have any comment on that? I just thought that was very interesting. Maybe some of our listeners have experienced that situation.
Yeah, it definitely happens. I don't think there's any magical solution against this, except, there's no magical solution against it, but I don't know. End of sentence.
Here was another question that might provide you some leverage to talk about, wax philosophically about the topic, and that is. This is a quote: "I am a Scrum Master with developers who are on multiple teams, and often they do not finish their tasks during my sprints because they end up working on new bugs or tasks in other team sprints. How do I hold my team members accountable to finish tasks?" Do you have any magic answer to that question?
Yeah, it's actually a quite different question. So maybe if you allow me, I'll say just a couple more words about the first question, because having said that there is no magical answer, I think part of the remedy, if not solution, but at least remedy, is to make sure that managers have technical abilities. There's still too many cases in which a technical team is being led by someone who is not himself or herself a software professional, or is someone who was a software professional 20 years before, but has graduated into management and is not familiar with the technologies of the moment. And it's much easier to fool someone like that than a real manager who is more of a first among equals among programmers. And I think the phenomenon that Ambler describes, which is real, arises much less if the manager is someone who is quite competent technically and to whom you cannot just tell tales. On the second question, how do you prevent people from misreporting or over-reporting or pretending that they have finished tasks that they haven't? Well, your correspondent is a Scrum Master. That's his job. His or her job. I don't know the gender. It doesn't say his to be, or let me say their job. It's their job to be to do this, right? That's my understanding of what a Scrum Master does. But technically, this is one point at which we can relate back to some of the questions that arose at the beginning of this discussion, in particular the role of tests. I mean, that's what extreme programming, Ken Beck and a few other people taught us, is that if you want to prevent people from just hand-waving, then you ask them to run the tests. And if we apply that part of the extreme programming philosophy, that there is no functionality without a test that goes with it, then it's much harder for people just to hand wave and say, yes, I finished this, believe me, trust me. You don't. Now, of course, I prefer specifications to tests. That's even better, or specifications as an addition to tests. But making sure that when there is this task list in Scrum, or function list, or function or user story list, for every item of functionality, whatever it is, user story, task, or whatever, there is one or more tests associated with it and defined in advance, before the user story gets implemented. Then it's rather easy to call people's bluff. They say, this task is finished. Well, okay, let's push the button and run the test. And either the tests succeed, in which case you're a bit reassured. It doesn't tell you that the implementation is perfect, but it tells you that at least something has been done. Or the test does not run, and then you start hearing the excuses. But this is one place where Scrum can benefit a lot from extreme programming.
Good. So we have time for one more question, but I'm going to pose two, and you can combine or into one answer or just take your pick. But they have to do with heterogeneous teams. Example, you have some specialties, developers who are user interface designers or versus software developers, or having a development team that's dispersed across the globe, geographically dispersed. And do you have any advice on what Agile or other method, or what aspects might apply under these types of program development teams?
Okay, in 2 hours or less.
2 minutes. We've got 4 minutes.
So let me just mention that I've published quite a bit about this, my colleagues and I, because of two reasons. First, the development team at Eiffel Software is completely distributed, so and it was not a choice. It happened. It just happened. So we have had for the past 15 years to develop good techniques for working together. And second, we have a course. So that's in the industry context, and in the academic context, we've run a course for almost 10 years now at ETH called Distributed and Outsourced Software Engineering, in which the project itself is distributed between groups of students working in 3 different universities. So altogether we have like 15 universities, but each group is made of students from 3 universities. So to summarize this experience in the 30 seconds or so that remain, it's hard. So when I start teaching my course about distributed software development, I say, here's the first law of distributed software development. Don't do it. Okay? If you ever have a choice between having everyone under the same roof or everyone in different places, the choice is very clear for the first solution. But of course that doesn't help, because usually you have external requirements that force you to do this. So let me give you in the minus 30 seconds that I have
please,
2 or 3.
Please go on. It's very valuable. Interesting.
So 2 or 3 concrete elements. First, laws of principles of software engineering really apply in that there are things that there are places in which you can cut corners if everyone is in the same room and meets at the coffee machine every morning, and which you can, and then you cannot cut the corners when you have a group in Zurich, a group in Bangalore, and a group in Kuala Lumpur. It just doesn't work. So, for example, the emphasis on interfaces. Interfaces should be very clearly defined. And even really small misunderstandings in an API, for example, can have terrible consequences. So that's an example of a technical piece of advice. And let me just give you one example of a non-technical piece of advice. And there would be, a dozen on each side. But let me give you just one on each side. On the non-technical side, contact is very important. You have to find a way to bring people together. And so this means, for example, that there should be regular meetings, Skype or Google Hangouts or WebEx or whatever it is, but there should be fixed times during which the team talks together. Email is not enough. Google Doc, all these tools are great, but they're not enough. People really need to be face-to-face or at least voice-to-voice regularly, at least once a week. In our team at Eiffel Software, we have 2 meetings every week, one agenda-based and one just focused on progress. So the one focused on progress just measures progress towards the release, and the agenda-based one is for deeper technical questions. So we need this communication, and also what I found is that things work so much better when for a distributed team, if once in a while, maybe every 2 years, maybe every year if possible, people can actually physically meet. You don't absolutely need to be together all the time, but just having seen what the other person looks like, having had, a coffee or a glass of wine with him or her a couple of times, even if that happens every couple of years or happens once at the beginning of the project and then never again, that makes a tremendous difference. You cannot completely substitute for human contact.
I agree. And with that, I'm afraid we've run out of time, and I'd like to thank you once again for taking the time to follow up on all the questions and the additional questions. And again, thanks to all the attendees for participating today. As usual, this webinar was recorded and will be available online in a few days at learning.acm.org/webinar. And you can find announcements for upcoming webinars on other ACM activities at learning.acm.org. And acm.org, we do have a high-performance computing webinar on Monday that you're welcome to subscribe to. So, as usual, please fill out the quick survey at the end of this talk that'll be you see right now. And this is Will Trace saying goodbye for now. Thanks again for joining us. Hope you will join us again in the future.